Hello guys, today we are going to create building destruction. First of all, I'm so sorry for being inactive for 2 months. I was busy on a project, and also my older PC got burned, so I couldn't continue the car one. Here I have made a new building destruction one. And I'm planning to do some RBD stuff till Jan end. Lots of RBD stuff are on the way. Stay tuned. This animation was from Mixamo and the building is made procedurally, which I found on the Japanese site. I will give the link to the building OTL and a sample HIP file of the building settings. Using that building OTL, we can create many types of buildings and towers which will be destruction ready. For the Mixamo, I had used 2 characters. 1. This Girl Scout T Masuyama character. From this one I will only use her baseball bat. 2. The other character was the boss. We will transform the animation from the hand to the bat. I used this animation name Standing Melee Combo. Once you downloaded both the characters with the animation, dive into Houdini. Take a Geo node. Take an FBX character import node. Here I will import the zombie one. Duplicate the node and import the second character as well. To apply the animation, we need to use a node called Bone Deform. Since we have the animation on the bone, not on the body, change the timeline to 1 to 100. Take a blast node to isolate his wrist and palm. Turn on Delete Not Selected. Now take an Extract Transform node. We will extract the Orient and Transform matrix from the hand. In the second input, connect the blast node. In the first input, take a Timeshift node and connect it. In the Timeshift, freeze the first frame. Now we have only one point, but that point has Orient and Pivot attributes. Now we need to isolate the bat from the other character. First, take a connectivity node and add a class attribute on the primitive level. Now take a blast node. We will use the class attributes to isolate the bat. Now take a transform node. Move the pivot to the center of the bat. Template view the Timeshift node for the hand reference. Now transform the bat so that the hand feels like it is holding the bat. Once you set the transform properly, take a Transform Pieces node. Connect the transform in the first input, and in the second input connect the Extract Transform node. In the third input, connect the Timeshift by freezing the first frame. Now let's merge both of them. Now if you see, the bat is properly moving with his hand. Take an attribute delete node and delete all the attributes except the UV. Again, take a connectivity node and a normal node. Now let's import the building. For the building, I found the link and got this OTL. This building is made from a procedural method and it is ready for destruction. I will show you the sample file. These all are the buildings made from that OTL only. I have not done any experiments, so I won't tell you how to create a building. You do some R&D on this and create a nice building and do destruction. Copy the building_1 node and paste it on our scene. Let's move all the nodes inside the subnet by selecting all the copied nodes and pressing Shift+C. In the BMK building form, set the floor to 14. Now we need to set the scale of the character according to the building height. Take a transform node. I had scaled from the centroid, we don't want to scale from the centroid. I corrected this later. Set the uniform scale to 20. Now take another transform node and we need to animate the character position, so the bat would hit the building on both the attack. I will fast forward this procedure. In this procedure only, I remove the scaling from the centroid. Take a trail node here. Set the result type to compute velocity. Now take a retime node. In the input range set 1 to 67. In the evaluation mode set fit range. Turn off the interpolate rotation of normal. This will a little bit messed up the velocity. Let's add another trail node. Let's move the bat a little bit more down so the bat in the end won't touch the roof. I moved the bat little bit down using the bat transform node. Add a null here. For the fracturing, I have used one OTL, which I will show you now. It's a free and nice OTL. So I have used this simple fracture OTL. You can see his tutorial on how to use this OTL. Take another subnet. Take a UV texture node. In the texture type select face. Let's scale the UV using the UV transform node. If you see, we already had a name attribute available on the geometry. We don't want to mess up the current name attribute. We don't want to mess up the current name attribute. So let's store that attribute as a name_original. Take a wrangle and write this code. Take a connectivity node and add a class attribute on the primitive level. Now take a split node and split the balcony frames. Make sure to select based on name attribute. In the end, remove the numbers and put a asterisk. By doing this, all the pieces will get selected. Take a Voronoi fracture and a scatter node. In the force total count select right 340. In the name attribute select append from the Voronoi node. By doing this, it will add the name attribute using the existing name. Now let's isolate the balcony glass. Take a for each connected piece and delete the connectivity node. In the Houdini 20, this comes with the linked parameter, so break this link and write the class here. You can fracture this glass based on your requirements. Although you can use simple Voronoi as well for the glass, I use this one will an extremely less detailed fracture. Increase the detail size to 5. Set the copy value to 1. Turn off the noise as well. Set the scatter points value to 5. Now the issue is, we will get all the glass fracture pieces of the same patterns if we display the end node. As you can see, all pieces are of the same size and pattern. To fix this, do the following procedure. Select Begin Node and click on Create Meta Import Node. Now in the seed value, we will call the iteration attribute from detail. Write this code in the seed parameter. Now if you turn on the single pass from the end node and change the value, you can see the seed value also gets changed. Turn off the single pass and let's see how the pieces looks. Now if you see, we have pattern variation in the glass. We have to repeat this process for all the pieces. Take a split node again. Here we will split the balcony wall. Duplicate the for each network and connect it here. Since this is the front wall section, we will add some detailed fractures here. Select Voronoi plus Boolean fracture. Keep the scatter point of Voronoi to 4. Set the detail size to 0.4. Turn on the noise as well. Go to the Boolean tab and set the scatter point to 1. Adjust the detail size as per the requirement. You can play with the parameters of the Boolean setting. Again, take a split node and split the floor. Now here if you see, we have the center floor as well. Since this is in the center, we don't want two small pieces here. So we will isolate the outer and inside floors. Again, take a split node. Select the center floors. Duplicate the for each network. Select Voronoi here. Set the scatter point to 15. We will have decent sized pieces here. You can play with the cutter details and noise. Duplicate the for each network again and do the same for the outer side floor as well. I will use 13 points. Let's reduce the noise setting here to get more natural looking pieces. Merge both of them. Split the roofs. For this one, we will not use for each. Just take the simple fracture node and fracture it. Split the roof fence. Fracture this using the Voronoi fracture node. I will use 40 scattered points. Make sure to change the name attribute to append in the Voronoi node. Split the wall interior. Here we will again isolate the interior wall and the exterior wall. Take a split node. Go to the top view by pressing spacebar +2. Now select the center walls and press enter. It will select the whole wall from top to bottom. Now duplicate the for each network. For this wall, if you try to fracture it directly, then it won't work. As you can see here. To fix this we need to remove the non-manifolds polygons and nans. Take a clean node. Turn off the remove to generate primitives. Turn on manifold only topology. Now if you display the fracture node then the issue would have been resolved. How did I figure out this solution? If you turn off this clean node and open the fracture OTL, by right-clicking and selecting allow editing of content. Let's find out where is the Boolean node. If you see the info here, it's written on manifold edges. You can fix the manifold using the clean node. Also sometimes only the clean node doesn't fix the issue. We have to use the divide node as well and add some more division. Take a divide node. Turn off the convex polygon and turn on the bricker polygon. Set the size to 0.7. You can play with the noise setting parameters here. Do the same thing for the exterior walls as well. You can play with the noise setting parameters here. Now split the wall outside. You can fracture this using the older method without the clean node. Since this is the extremely outside wall, we need to add more pieces here. Set the fracture setting according to it. The remaining are window frame and window glass. Split the window frame. Copy the balcony frame fracture network and paste it here. Set the scatter points to 1000. For the glass fracture also we will using the same method that we used for window frames. Now merge all the nodes. Here I forgot to merge all the nodes. But you don't forget it or else it will again take lots of computing power. If you see we have some unconnected points, use a clean node to remove them. Make sure to turn off Remove to generate primitive. Cache it to disk. We need to cache only a single frame, so turn off the time-dependent cache. Now again take a connectivity node. Set the type to primitive. In the attribute name write temp class. We already have a class attribute here, but this contains a bunch of pieces in a single class attribute. We are doing this because we had fractured using the loop, and because of that, the name attribute is messed up. If we see the new connectivity and visualize the temp class attribute, you can see we have it present on each fractured piece. Take an attribute wrangle node and write this code. Make sure to change the runover to primitive. Now we have the correct name attribute for each piece. Add an exploded view and see what the pieces look like. If we turn off this wrangle, then you can see what this looks like. This is happening because of the duplicate names. Now we will create the constraint and the proxy geo. Take an RBD pack node. Take a connect adjacent pieces node. In the connection type, select adjacent pieces from surface points. Set the max connection value to 5. Also, we need to turn on the rest length attribute. Now we need to copy the class attribute to the constraints. Take an attribute promote node. In the original class select primitive. Promote the name and class attribute. Now take an attribute copy node. Turn on a match by attribute and write name. Copy the class attribute. Doing this, it will copy the attribute by looking at the similar names present in both the wires. Connect this to the second input of the RBD pack. Now take the convex decomposite node. Here, make sure to set the concavity value according to the PC config. I have 24 cores, so I'm going to down this value around 0.24. For me, it took around 3 minutes to compute. If you have 6 to 10 core, then go for 0.6. We will have some unconnected points here as well. Take a clean node to fix this. Connect this to third input of the RBD pack. Cache this out as a single frame. That's it for today. In the next part we will see the simulation part. Thank you guys for watching. See you in the next video.